This is a review for 5.1 to 5.6 and then 5.9. Here are some of the topics that will be covered on tomorrow's quiz. Make sure you know the memorization of the quadratic formula and how to use it and how to find the discriminant. Remember, the discriminant is underneath the radical in the quadratic formula. And it tells you if you have a real solution or a complex solution. If you have a negative underneath the radical, that discriminant is a negative. That means you have a complex zero. There will be an application problem on there, like a word problem, dealing with quadratics. Being able to add, subtract, multiply, and divide with imaginary numbers, reducing down if there are radicals, being able to use an absolute value of a complex number, being able to graph a quadratic function, graph a parabola, find its important pieces like the x-intercepts, the y-intercept, the vertex, maybe the axis of symmetry. Does it open up? Does it open down? The last topic is being able to convert to vertex form by completing the square. So what I have is just some topics within this slide. So if there's things that you're not comfortable with, it's been a while since we've done a quadratic function in graphing, so I thought maybe that might be a place you want to start. And if I just kind of show you ahead, this is a problem where we could find the solution using the quadratic formula, finding the discriminant and the types of solutions, converting to vertex form by completing the square. These are just your imaginary numbers and some topics. So these are a little bit more current, so I thought maybe we might go backwards to more of the earlier in the chapter topics. And then a couple application problems. So do you want to maybe start with the quadratic function and graphing that? Might be a good choice? Okay. All right, so these are just the things. And what I'll do too is I'll put this on ClassJump as a PDF when we're done with it, so you can view the answers and stuff like that in a paper form. Okay, so here's a quadratic function. Remember, quadratic functions can be in three forms: in standard form, in factored form, or in vertex form. This example is in what we call factored form. So if we want to find the x-intercepts, do you remember what we do to find the x-intercepts in factored form?
Set y to 0.
Set y to 0, yep. So I'll just push this up. So remember, f of x represents y. So what it looks like right now is y equals x minus 4 and then x plus 3. Now you said set y to 0. So it looks like this. Now what do I do in that next step? What would I do next to find the x-intercepts? 0, yes, and that's called the zero product property, where we set the factors equal to 0 and we solve for x using the zero product property. And what we are doing is we're finding the zeros of the function. So we set those equal to each other, and then we solve by undoing. So we would add 4, and we would subtract 3. Now we don't want to leave the answer like that. We want to leave them as ordered pairs. So what would be them as ordered pairs?
4, 0, and negative 3, 0.
Yep, 4, 0, and then negative 3, 0. Do you remember how to find the y-intercept? Or, yeah, the y-intercept.
Don't you have to FOIL it out and set both of the x's to 0?
Yeah, you could FOIL it out. You don't have to necessarily, but you could sub in right away, 0 in for x. So let's do that next. So I have that, again, y equals x minus 4, x plus 3, and I would sub in 0 now for x. So I always have to think opposite on those. So 0 minus 4, 0 plus 3, and then I would reduce that down. negative 4 times 3, which is negative 12. Now, if you did the other way where you converted it to standard form, or if it was in standard form, the C is the y-intercept. So what is the y-intercept here as an ordered pair? Yes, 0, negative 12. The vertex. How do you find the vertex? Let's graph out what we have, just the x-intercepts maybe, to help us. So this would be 2, and 4, and negative 3. Whoops. Negative 2. Negative 4. Where is the x of symmetry if I have those two x-intercepts? The middle of those two, yep. Or I could convert it to standard form and take opposite of b over 2a. That finds the x value.
I think the axis of symmetry is 1.
Is what? Is 1? Do you guys agree? What's the halfway point between negative 3 and 4? Use the midpoint. Negative 3 plus 4 divided by 2. Negative 3 plus 4 is
Just 1.
1 over 2. So the halfway point between negative 3 and 4 is 1/2. So there's half of your answer. That's your x value. So the x of symmetry is going to be right through 1/2. And then your x value of the vertex is also going to be at 1/2. How do you find the y value of the vertex? Think of it as in standard form. If I take opposite of b over 2a, and I get that x value, what did we do next to find the y value of the vertex? Plug it in. Very good. We plug it into the original function. So if my original function looks like this, y equals
It's minus 4 plus 3.
x minus 4, x plus 3. We sub in 1/2 in for x. So we get negative 3.5 times 3.5. And what's that in your calculator? Negative 12.25. So that's the y value of the vertex. Remember, the vertex represents the maximum or the minimum point. So I have a y-intercept, and I'm going to just change the y-axis to every 2. So this would be negative 4, negative 8, negative 12, negative 16. If I graph the y-intercept, it'd be over 0, down 12. And then the vertex would be over 1/2, down negative 12.25. Can we see the parabola now? It goes like this. It goes like that. Now let's talk about the up and down. Does this parabola open up or down? Up. You can also look at it from the equation. If the leading coefficient is a positive a, then it opens up. If it's a negative a, it opens down. So does my vertex point have a maximum or minimum? Minimum, it's the bottom. Okay, good. Now there are 2 other forms, remember, of quadratics. There is still this form, where we have y equals ax squared plus bx plus c. And then at standard, And then we have this form, y equals ax plus or minus h squared plus or minus k. What's that form? Vertex? Vertex. Okay. I'm going to stop the recording there because we're at about 10 minutes, and then we'll do some more problems.